Hey everybody, so today I've got two videos that I'm going to do. One is I'm going to do just the notes in one and then examples in the other video. And again, there'll be copies of this posted in today's folder also so that you can go back and look and write this down. So what we're going to be looking at are transformations of exponential functions. So what we looked at on Monday, for every exponential function that we were looking at, whether it was 2 to the x, 5 to the x, 1/2 to the x, 0.8 to the x, whatever, it was just a number to the x. We're going to look at, okay, what if there's other things going on in the equation? Add, subtract, multiply, and divide. How does that move the exponential function? Because for all of the ones we looked at on Monday, they had the same asymptote, which was the x-axis. It never touched, but it got really close to. It had the same y-intercept, 0, 1. Same domain, negative infinity to infinity. Just some were increasing, some were decreasing, and some were steeper than others. So what we're going to look at today is now how does that graph move around on the graph and things like that. And we'll think back to transformations that we did earlier in the year, and hopefully that will help with some of this. So first we're going to look at a horizontal shift. Which is moving left and right. So taking that curve and moving it left and right. Alright, so if we have a number, we're going to use the letter C here, that is being added to x. Now, if we think back to when we did transformations of our parent functions back in September, October, the horizontal shift was adding and subtracting to x on the inside of parentheses or absolute value or radical. So this is that same idea. This is adding and subtracting inside, really means to the exponent. So this plus c, it's opposite of what we think with the horizontal shift, just like it was when it was inside the parentheses and all that. So this is going to move it to the left that many units. And if you have some number that's being like x minus 3, that would move it to the right that many units. So we have our horizontal shift. Then we have reflection if we just stick in that same order that we did our other transformations. And so when we had the negative to the whole function on the outside, this is essentially the outside. That reflects the graph over the x-axis. And when we have the negative on the inside, or here on the exponent, that reflects it over the y-axis. So same idea as when we did transformations before. Then we're going to look at stretch and shrink, but instead of using the word stretch and shrink, all I want you to look at and be able to identify is, are you making the graph steeper or less steep? Is that curve growing exponentially faster and steeper, or not as steep? And that's by multiplying by a number. So whether you multiply it by the function or by the exponent, okay, as long as the absolute value of c is greater than 1, that's going to make it steeper.
Here in the building, call 3102, please.
And to make it less steep or wider, we said sometimes, we're doing the same thing, but this time what we're multiplying by would be between 0 and 1. So a number like 1/2, 1/3, 0.8. So yesterday, again, those numbers make it less steep. The higher the number makes it steeper. So if we multiply by a number that's greater than 1, that makes it steeper. Between 0 and 1, that makes it less steep. And then the last thing we have is our vertical shift. And that's what moves it up and down. And that's adding and subtracting to the whole function to the outside. So if you have your b to the x, so like 2 to the x plus 1, this plus 1 on the outside moves it up that many units. And subtraction moves it down that many units. Alright, so hopefully you've written this down. I am posting a picture of that. If you want to print it out also, you can do that because you will need this for the examples that we're going to do next. Thanks.